And grab the two warm-ups for today, which is going to be I think it's 14 and 16. Does that sound right? Yeah, that's right. Okay, let's go over this again. So the first thing you do is make a table. And your table has to include the 2 points that you're given, but it also has to include 0. 0 is in between these two, so we just need to make sure we have a spot for it. Yesterday, we had these two, the 2 and the 5, and we had to backtrack to the 0. So make sure there's room for the 2 points you're given, and then also make sure there's a spot for 0. Okay, -2 is 3,200, and +2 is 12.5. Any questions about my table setup? Good so far? Okay. Now we're going to count. 1, 2, 3, 4. It takes 4 multipliers to get from this spot to this spot. So I'm going to write 3,200 b to the 4th equals 12.5. Why do I feel like it's going to be gross numbers again? Did anybody do it yet? Is it gross numbers? Nah. All right, everyone, behold one of my birthday gifts from yesterday. Behold it in its beautiful brand new glory and tealness. Are you as excited about it as I am? Now I get to leave the other one at home. I know. I was excited to come to work today. Mr. Talbot certainly knows how to buy birthday gifts. Okay. 12.5 divided by 3,200. Okay, now I highly suggest that you can round this decimal on your paper. Do not round it in the calculator. You can round it on your paper, but don't round it in the calculator. The reason is because it'll come out evenly if you don't round it. So this is what I suggest we do. First of all, we need to 4th root both sides. And then you're saying, how do I 4th root in this brand new, beautiful graphing calculator? The 4th root is located in the math menu. You just need to, I always tell it 4 first. So I hit the 4 button because the 4 is right here. Then I hit the math button, which is right underneath the green one. Oh, mine's yellow. Who knew? Then scroll down to the one that says X root, which is number 5. And what the calculator will do, especially if you have a newer one, it'll take that 4 you put in the front and plug it into the little root spot. Anybody want me to show that again? Yes? Okay. So let me zoom out a little so you can see. But first hit the 4, like just the plain number 4. Then the math button. Then scroll down to number 5, which is the X root. And it should plug the little 4 into the root spot. If you have an older calculator, it won't look like it did it, but I promise it did. Okay, now, how I was saying don't round in the calculator, this is where we're going to be smart. We're going to take our up arrow and scroll up to this decimal so it's highlighted, and then hit enter, and it'll copy and paste it in that spot. Isn't it weird that the fourth root of that ugly thing is something not so bad? Kind of feels weird, but okay. Now we are going to get A, and we get A by going down the table this time. So we're going to go 3,200 times 0.25. That's 800 times 0.25. And that's 200. So A is 200 because it's the start right next to the 0, which is why we need the spot for the 0. Final answer, y equals 200 times 0.25 to the x. Yes, nope, you can. As a matter of fact, I highly suggest it because it's a really great way to check your answer to make sure that if you multiply by 0.25, it makes sense for this, and then multiply by 0.25 again and make sure that it's 12.5. I'm just too lazy. Any questions about exponential through 2 points? We're going to do this again coming up. I don't even know when it is yet. I can't remember, but some point in one of the upcoming lessons, we're going to add horizontal and vertical shift to this, but not for now. Just let that go. Okay, now let's go to the piecewise, your fave. You know how you love it. You woke up this morning, you're like, oh gosh, I really hope Mrs. Talbot does that piecewise warm up because that's just, it makes so much sense, this notation here. I got a lot of feedback yesterday about who knows this already and who doesn't. Okay, let me ask you some questions. First, how many pieces does this graph have? 3. Piece 1, piece 2, piece 3. Okay, next question. How many tables should I make? 3, 1 for each piece. Okay, if you can do that, you're on your way to being able to graph piecewise. Oh, I get to use my new beautiful. Okay, my first table is going to be x and -3 to the x. I'm not just putting y there because I want to like make sure I know this is for the first piece. X and 4, x and x minus 4 squared. Okay. Any questions about how many tables or how I set up the tables? Okay, now we're to the hard part. This says for my first piece, x is less than -2. So I'm going to go, I am still going to put -2 here, even though it says less than. It's going to be open, but just hold that thought. And then I'm going to write numbers less than. So I'm going to go down, 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 down. So it's starting at -2, going less, 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 less. Okay, my second table says go from -2 to 3. -2, -1, 0, 1, 2, 3. That one's easy. It tells us both sides. And this one says x is greater than 3, 3, 4, 5, 6, 7. Okay. Now I'm going to plagiarize. Not really. I'm just being funny. -3 to the x. Okay, so -2 is -0.1. -3, -0.04. -4, -0.01. -5, 0.004, -6, -0.001. Gosh, I feel like there's an asymptote situation there. Okay, before I finish this table, which one of these points is going to be the end point? Let me help. Which one of these points is going to be the end point? -2. And is that endpoint going to be open or closed? Open, because it does not have the or equal to on it. It's just plain less than. Okay, now let's move on. Well, the second table, we could type this into the graphing calculator, but then I should be left out of here. This is telling us that y's are all 4. It's going to be a segment that's horizontal. Okay. Coming back up here, what are the two endpoints for this table? Yeah, -2 and 3. And are they open or closed? Closed. Okay, so we're going to make this. We're going to say that's going to be closed. Closed. Okay, so copying off the table here, 3 is 1, 4 is 0, 5 is 1, 6 is 4, 7 is 9. Okay, 3 is the endpoint and it's open. Any questions about my giant amount of table setup? We're good? Okay, so now we're going to graph -2, -0.1. See how it says open? Make your circle obnoxiously open. Pretend that your teacher is, almost blind. Like, pretend that she is so old that she's using a walker with tennis balls on it. And you have to make sure that she can see the open circle there. -3, -0.04. So you can tell this is a piece of a hyperbola that is getting closer and closer to the x-axis, but not touching. Okay, now I have -2, 4 is closed. Closed to make it an obnoxious dot. -1, 4, 0, 4, 1, 4, 2, 4, 3, 4, another obnoxious dot, and then connect them. Three, 1 is open. I don't know if that's open enough. There we go. 4, 0, 5, 1, 6, 4, 7, 9 is going to be off like right here. And there are our 3 pieces. All right, when you're ready, get back to your notebook, please. Today we're going to learn about what functions are called even, what functions are called odd, and what functions are neither even nor odd. This is kind of abstract. You might not love it, but with practice, people will be fine. Just the first day. After that, I'm going to give you guys some time to look over your notes for the quiz because I need to warn you. The first question is to use the vertex and a point to solve for A. Do you know what I mean when I say that? If you don't know what I mean when I say that, then you gotta figure that out in the next 30 minutes. But you have to make an equation out of that, and then you have to use that equation to identify A, H, and K and describe the transformation. If you don't know how to solve for A, you're gonna miss the entire quiz except for the 2-point trig problem at the bottom. Because you need the equation to be able to find A, H, and K and describe the transformation. So I'm going to give you a little bit of time to look that over again, and then we'll do the quiz. Oh, and homework is 76, 77, 79, and 81. And the 8 and the 4 say, oh, how cute. He has an imaginary friend. Do you see his imaginary friend? Yeah. Mrs. Talbot, why didn't you have these notes when we did the imaginary numbers notes? I don't know. I should have done this one the other day. It's fine. It's all good. Okay. So this is abstract. I know that. And sometimes people don't love that, but we're going to do our best. I'm going to try not to go too fast so that you can see what to do, but I also don't want to go too slow because then you don't have enough time to study. So we have to balance it out. First, I am going to find f of negative x. What that means is I'm going to take a different color here. I'm going to put negative x in here and negative x in here. Okay, so f of negative x. So I took this x and replaced it with negative x. And I'm going to take this x and replace it with negative x. Does anybody need me to say that one more time? Okay. In this box, I'm going to take -1 times the original function. So -1 times f of x equals -1 times x. What I want you to imagine is that I times both sides by -1. Okay, what's -1 times x? Negative x. Okay, and the fact that these two match is a thing. So I'm going to get a highlighter and I'm going to highlight this negative x and this negative x. It's a thing. I'm not going to tell you what the thing is yet. I just want you guys to keep your eyes open for matching, stuff matching. You don't have to do a highlighter. You could maybe put a box around them, check marks, anything. Okay, and you can see these are going to go kind of quick. So on this one, I'm going to change this to a negative x and this to a negative x in the first box. So f of negative x. So I put negative x there. And then on this side, I'm going to put the negative x in parentheses. So that became negative x. That became negative x. What's a negative times a negative? Positive. Great. Okay, now I'm going to multiply both sides of the original by -1. So -1 times f of x equals -1 times x squared. So I put a -1 in front of this, and I put a -1 in front of this. What's -1 times x squared? Negative x squared. Okay, now you notice right away that these two definitely do not match, but it's also a thing that these two match. So come back with your highlighter. Okay, you guys getting the hang of it? Okay.
Well, I just don't get like how one matches
Oh, that we haven't talked about that yet. Yeah. All I'm worrying about is plugging in and multiplying by -1 and looking for matches. I'll discuss why they matches in a little while. Okay, so f of -x equals, okay, so I put the negative in there, and now I'm going to put the negative in there, -x cubed. Nope, lies, I did it wrong. Do you see what I did wrong? The cube is supposed to be outside. Okay, what's a negative times a negative times a negative? Negative. Okay, so looking for patterns, these two don't match. -1 times the original is -1 times x cubed, which is -x cubed. Aha! We found matches. Okay. So now I put the -x here, and I'm also going to change that to -x. What is the absolute value of a negative? Positive. Do you see the matchy already? Okay, we just talked about this yesterday and on the joke today, actually. This would be I square root of x. These things definitely don't match. This is our first one where we have no matches. It's actually much more common to have no matches than it is to have matches. Matches are special. We set you up with special ones, but usually they don't. So this is not unusual. Okay, this is a fun thing to talk about that's important and helpful for the rest of your life. If you have a negative in either the top or bottom of the fraction, you can pull it out to the front. But if you have two, you should cancel that. Always a good thing to clarify. we're back to matching again. Okay, last one we're gonna mess with is 2 to the x, an exponential. So I have f of negative x equals 2 to the negative x. Okay, this is hard but important. What do we do when we have a negative exponent? That's a fraction exponent. That's a fraction. We did it on the scavenger hunt of all that review stuff in chapter 1. Negative exponents, they end up being reciprocals. So they go to the bottom. Always good for us to review that. But, well, I mean, the moral of the story is these two things definitely don't match each other. And these things definitely do not match each other. So we have another one that doesn't match. Okay. So we're going to start with the ones that match, the two that match the first, the original, and the f of negative x. So we're going to start with these two. These two have column 1 and column 2 highlighted, and column 1 and column 2 highlighted. All right, that is x squared and absolute value of x. X squared and absolute value of x are called even functions. Did you get raving reviews? Like at the dentist? I always try to be the best dentist student. Okay, now you guys relax for a second. I want to show you what happens to these graphically. So we're just going to look at x squared. Okay, I'm going to attempt to pull out some whole vocab here. What do these two things have in common? They have a lot of things in common. I'm looking for something specific, but will love all guesses. What do these two things, the red and the blue thing, have in common? Anything they have in common. Perfect. Yep. Yes. Okay, pause there. That's what I'm looking for. They have the same line of symmetry, a very special line of symmetry. What is their line of symmetry? Oh, I'm going to say more specific. It's the y-axis. Okay, so if I folded this paper on the y-axis, this would match up if I folded that, is what I'm saying. Okay, this is, there's some very specific vocab we learned. I think, I don't know. Math teachers all over the place. I tell them this at lunch every day. If you guys could just agree on something, that would be awesome. And they don't. But, you know, a girl can vote. Anyway, and then Mr. Guinan says, well, they're all going to say that they didn't see it anyway because they don't remember it. And I was like, okay, that's true. That is true. But anyway, this is called reflection symmetry. Reflection symmetry means that I can flip this over and it's reflected on the y-axis. So in academic vocabulary, we are going to say even functions. Hold on. All even functions have reflection symmetry on the y-axis. I was also kind of hoping to hear that they have the same domain and range because we talked about that in the parent graph organizer, or that they were all mostly located in quadrants 1 and 2, or all above the x-axis. Those all would have been good things that they had in common also. But okay, now we're going to look at the ones that have column 2 and column 3 both highlighted and match. And there were 3 of those. That was x cubed, and 1 over x. Can you guess what those are called? I want you to note that x squared has an even exponent and x cubed and x have odd exponents, but that's not really the definition of even and odd. It's probably the start of it. But it clearly absolute value of x doesn't have an even exponent. So, but anyway, so I'm going to take these two guys off. Y equals x. Y equals x to the third. Y equals 1 over x. Other than this being a wickedly cool graph, what do these have in common? They do. A very important point. Yep. So they all go through the origin. This is extremely important here. Okay, so I want you to think about what we wrote for even and turn your brains into that sort of same word. Do you remember anything else? Any other kinds of symmetry? Other than reflection symmetry, there's a different kind. Rotation symmetry. Okay, these 3, were you going to say it? No. So, no. These 3 all have 180-degree rotation symmetry about the origin, which means that if I took my computer monitor and flipped it upside down, it would be exactly the same graph. Exactly the same, and through the origin. All odd functions have 180-degree rotation symmetry about the origin. So I'm going to show you on this real quick, just with x cubed, because I actually can flip this upside down. So here's x cubed. And then same exact graph, 180-degree rotation symmetry. The other 2 we looked at didn't have anything match. So those are just neither even nor odd. That's most functions, to be honest with you, are neither. Okay, last thing we're going to do here is last problem's not short. We're going to do notes on this because it's a little bit spicy. But I want to go as quickly as humanly possible for your studying purposes. So if you guys could write quickly when I turn this notebook over. Yeah. Alrighty, guys, so I'm just gonna start filling these formulas in. Even functions, the original function is the same as f of negative x. For even functions, the original function is the same as f of negative x. Graphically, you can tell because it has reflection, symmetry on the y-axis. So that was the first column in our table, matched the second column in our table. And those are the ones that reflected on the y-axis, the first ones we looked at. Odd functions, f of negative x equals -1 times the original. So this was the second column equaled the third column. And these ones all had 180-degree rotation symmetry. About the origin. So that's the notes bit. And then we're going to do 3 examples. We're going to do one that comes out even, one that comes out odd, and one that comes out neither, so that you can see exactly what the difference is between them. Okay, what I like to do is I like to make a little baby table of what we just did. So I put original, f of negative x, and -1 times the original. These were the 3 headers of our table that we did on the other side with the highlighting. I just like to make a little baby one just for this problem. Underneath f of x, I just write the original function. So I just rewrite the problem. Regular old x squared plus 2. Everybody okay with that? Okay, in this one, I take the x and I replace it with -x. Again, in this one, I take the x of the original and replace it with -x, always with parentheses. And then I say, okay, a negative times a negative is a positive. So that comes out to be x squared plus 2. Technically, you can stop here because once you find that it's even, you can stop, but I'm going to do the whole thing. -1 times the original. -1 times the original. And then distribute that negative. So this is what our table would look like for this particular problem. And then I look for matches. This matches this. Column 1 matched column 2, which means that this function is even. Okay, now what I'm going to do is use my graphing calculator real quick to make a little baby sketch of this. Just to verify, this is me checking my answer. Oh, it's not just because I wanted to get my new calculator out or anything. I really would do it, I swear. Okay, does that look like reflection symmetry on the y-axis? Yes. Okay, so we're just going to sketch it in. And this checks our algebra. Make sure that we got the right answer. Do you guys see how these are going to go? So I'm going to do my little baby table bit, see what matches, and then check my answer with the graph. Okay, number 2. Original f of -x -1 times the original. Original, -0.5x cubed. Okay, now in this one, I'm going to take this x right here, and I'm going to put -x in parentheses. So -0.5 -x cubed. Okay, important question. How many negatives are there in this problem? More than 2. More than 3. Less than 5. Okay, so there's, if you look up here, there's technically 3 of them because of the cubed and then the 1 in front. So this counts for 3 negatives, and then you have the 1 in front. Negative times a negative times a negative times a negative is a positive. You guys ever get stuck? Just write down -1 times -1 times -1 times -1 if you have to. -1 times the original is 2 negatives make a positive. So what is this one? I have the second column matches the third column. Mm-hmm. All right, now I'm going to draw a baby sketch. Does that look like that has 180-degree rotation symmetry about the origin? Indeedy. Okay, I already kind of blew it and told you that this last one was neither because I said one of them was even, one of them was odd, one of them was neither. But let's pretend I hadn't said that statement. What would you suspect this one might be? Just from the exponent. Would you expect it to be even or odd? Maybe. Odd, right. Okay, so it's probably not even. You can say that. Let's talk about why it's not odd in a second. So original f of -x, -1 times f of x. Original -x cubed plus 2. So this is a negative times a negative times a negative, which is a negative. From my algebra, nothing matches. So I'm going to say it's neither. And then I'm going to be like, that's weird. It's a cubed. I better check on the graphing calculator. Oh, but that looks like it has 180 degree rotation symmetry. But the question is, if I turn my calculator upside down, is it exactly the same thing? No, now the inflection point is below the x-axis. This one's not going through the origin is the problem. It's shifted up 2 units. Has to be reflection about the origin. So I'm going to draw like this, inflection point.